Hey everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 26. And today I'm joined by Callum Linington to talk all about event sourcing. So hey Callum, welcome to the show.
Hi Dan, thanks for having me. This is exciting, isn't it?
Oh, it is. I'm really looking forward to this one. So to give you a formal introduction, Callum is a principal engineer at Clearbank. He's a professional software developer working on the .NET stack, and according to his Twitter profile, he's also a music and rugby lover, and gym lover and hater. So I'm kind of with you on that last one because, well, my gym habits are kind of like a sine wave. Sadly, at the moment, I'm at the bottom half of that wave.
Yeah, it's interesting actually because I was actually talking to this with my osteopath the other day, which tells you how, like, you know, when you're having a bad time at the gym, you're at the osteopath. And he was saying he just dreads going and doing leg day because leg day is a make and break day. You go and do leg day and you're like, oh, this is amazing. I feel like I'm on an absolute high. But then as you're walking down the stairs and you realise your legs are really wobbly, you know that you're in for a week of not being able to sit down, stand up, walk anywhere, just do anything. You just basically have to sit on the sofa all the time. So yeah, that's why I'm a lover and a hater of the gym.
So the solution is don't go to the gym and sit on the sofa all the time. Anyway, it sounds quite good.
Yeah, just put a laptop on the legs and just go and just code away. Just never stop. Sounds ideal.
It does, doesn't it? I do like that your LinkedIn profile also says that you're also known as a code connoisseur. I do love that. What a great phrase.
Yeah, it came out like right at the beginning of my career, and I always have a fondness for patterns. It's just like the way that my brain works. I see everything in patterns, and I think it's just like one of those things that probably just drew me towards programming. And just seeing all these patterns and how they all interconnect. And then also when you see those really beautiful snippets of code, like you've seen the recent one from like David Fowler about, you know, the minimal API stuff where, you know, like C#, soon you're going to be able to write a running API in like something like 10 lines or whatever without any braces as well, which would be interesting.
I've seen a whole bunch of his tweets with lots of different, I think there's been lots of iterations as it's got smaller and smaller and smaller.
Oh yeah. And have you seen the inclusions of the WebSocket stuff as well? Like that, because that and event sourcing, like I'm just on that part. Like that's what is the most interesting. And yeah, so like I just sometimes I just stare at code for a while and just, you know, look at it and think about it and just love it. And like, you know, we can make these tweaks to do this, that, and the other. And someone just turned around and went, you are like a code connoisseur. And I was like, yeah. And I just, you know, like if you sit there with like a whiskey glass or whatever, and you're just swirling the whiskey around. That's just what I do with code. I just swirl it around, give it a smell. Oh, it's quite nice, actually.
Oh, that's brilliant. What a great tagline.
Yeah, love it. So that's why I put it there. I was like, you know what, that is probably most aptly describes me. I love looking at code. You know, I just love looking at code.
Awesome. So before we jump into event sourcing, I'm going to quickly give a quick listener mention. And this episode's listener mention goes to Danielle, who on Twitter is DanielleD_dev. And she tweeted, another great Unhandled Exception podcast episode on dependency injection. And she's referring to episode 24, where I was joined by Steve Collins. And Danielle also left a screenshot in her tweet of her podcast app, and it did say less than 1 minute left. So we now know that at least one listener has made it to the end. That was such a fun episode to record, though. Numerous times Steve and I fell into fits of giggles and had to stop for a bit. So I think I should probably release an outtakes version of that episode.
I think that adds another dimension, doesn't it? Adding the outtakes. Like, there's definitely going to be, I don't know, there's definitely times where you're just going to mess up and you think, oh God, that's just, yeah, get that on there. That'll get people glued in.
That would actually be a good idea because with the Patreon thing, I've been wondering if it's worth using something like that, but I didn't really want to add adverts or basically add anything to episodes that it would annoy people that weren't paying. So I decided against it. But actually, having outtakes for Patreon subscribers, that would be a good idea.
Yeah, that would be good. I think it's one of those interesting things about like the freemium stuff, like especially in games and stuff. You've got to be really careful, like how you up the levels and like you giving people sort of like the unfair advantage just because they can chuck a bunch of money at it. But it's by the by, really. But yeah, that'd be pretty cool. I'd pay for your outtakes.
Nice. I've got one customer.
I'd have to, because so what I do is like going back to like I've listened to like some of the previous podcasts, all the F sharp ones. Like I was all over the F sharp ones because I love F sharp, and like so many times I just wanted to like chime in, like, hey, I don't want to say something, but realizing it's like a pre-recorded podcast. I ended up doing like I've got a walk which takes exactly 1 hour to get around that walk, so I generally like listen to your podcast on that go. But if I started listening to the outtakes, I don't have to like do it again just to listen to the outtakes.
So, question, and I'm embarrassed saying I do this, but sometimes we'll listen to podcasts exactly for the reason that you say. I feel I've got to pause it and think about my thoughts about it, and then unpause.
Yeah.
Because I've kind of like, it's almost like I'm not getting involved in the conversation, but sometimes I feel pulled into a conversation if it's a really good conversation in a podcast, and I feel pulled into it, and I almost have to pause and think my thoughts through.
Oh, I have to say, like, there's been a few podcasts of yours which I've listened to that have just sparked so many thoughts in my own head that honestly I haven't listened to them for like I've missed 25 minutes of the stuff because I'm just thinking about something else as I'm walking around. I'm like, oh, hang on a minute, I'm listening to a podcast. I got to get back into this. Like, and then like someone will say something else, and it'll trigger all these other things I'm thinking about. So, yeah,
I have to pause it because I hate missing things, so I have to pause it while my mind wanders. Then I realise that I've zoned out, then I unpause it.
Yeah, I do that too much, so I just lean into it. I'm just like, I'm going to miss something. It'll be fine. I'll just carry on. I'll give a re-listen at a later point anyway, because I know I'll forget it all by, I'll give it like 6 months and I'll give them all re-listens.
There's too many ongoing podcasts being published. I subscribe to way too many podcasts. I wouldn't have time to re-listen to things, so I've got to make sure it soaks in the first time. I
can't listen to podcasts unless like I'm doing something like a walk where I've literally only got one thing to do and I'm walking and so. But I've still subscribed to quite a few podcasts, so it's like I'm going to have to just end up just doing laps and laps and laps of this one walk that I do, just so I can consume all that content.
Yeah, I tend to listen on walks whilst I'm doing the dishes or something. I've basically got my headphones on all the time, and generally I should really be more present for the kids and stuff.
I was going to say, just blocking out the family, just like, I'm listening to podcasts, go sort yourselves out.
Well, that's why these bone conduction headphones are amazing, because you can actually hear everyone as well, but listen to stuff in the background. But yeah, I should probably be a bit more present anyway.
I wait for the time that you start answering questions to things that people haven't asked in the room because you've got something going through your headphones instead. And everyone's like, which conversation are you in?
Well, it's good because I can answer the phone on it as well. So, because I wear them all the time now, because you can't tell I'm wearing them because they don't go over or in your ear. And if I answer the phone and start talking, it just looks like I'm talking to myself.
Or if the most brilliant one, if you're actually sat there having a conversation with your partner, like almost like a foot away from their face, you're having that conversation, suddenly you go, hey, yeah, how's it going? You all right? And she's like, what on earth you did? Oh, yeah, sorry, I've just got a call. Hang on. Those have got to be the best.
So we should probably actually talk about event sourcing, shouldn't we?
Yeah, probably at some point. I don't know if we'll actually ever cover event sourcing in this because it's there's a lot of other stuff to talk about. But yeah, absolutely, we should start somewhere.
We'll see what happens. So maybe we should start at the beginning and talk about what the term event sourcing actually means.
Yeah, so this is the interesting part because it's actually like stupidly simple. And as part of that, I've wrote so many notes around all this stuff just to like prompt me on all these different areas and stuff. But like the one thing is like, looking up a nice clean definition of event sourcing is actually really easy and straightforward. So event sourcing is a pattern for storing data as events in an append-only log. I wouldn't hang off the word log too much. I think some people might, think when they think logs, they literally think when you do console.writeline or when you stream off to Serilog or something like that. So don't think about it like that. It's just a log, more the conceptual term of like a log of events. So that's basically all it is. It's a very, very simple concept. And it is, I think the other thing to like note as well is storing data. So it is still a database in a certain sense. It just organizes the data in a different way. So that's it.
So is one key thing that each of these events has a timestamp, so you've actually got a history of things that have happened?
Yeah. So I'm probably going to keep referring back to event store because event sourcing is this thing that I'm currently looking at as well. And I've been on this journey, and we'll get through to this journey because I kind of like that, trying to show you how I sort of got there. But yeah, so I'm going to probably refer back to like Event Store, which is an event sourcing database. And I generally just spin that up in a Docker file. In fact, I use Docker Compose because there's a certain feature of it which only works if you use Docker Compose. So I usually spin that up in Docker Compose and just start connecting and reading to that. And the way that they do it is they have sort of like a core event object. And in that object has like sort of the date on it and the time and then the payload for the data and then some other attributes and things like that. So you can sort of annotate that. And then your event goes in that event. And then that event then gets actually published out into the event store. So it is append-only log. So the append-only means that you're constantly just writing new bits of data. You never go back and change something. And you basically get these sets of events. As being developers, you sort of want to categorize and group things together. So you get a set of events and they create an event collection called a stream. So you get these event streams and then that goes into what's called an event store. So the event store is actually just a concept, not an actual... Even though there's an actually event store database, an event store is actually just a concept of storing events as a collection of streams, which are a collection of individual events. Interestingly, actually, as I've been playing with it, and a stream doesn't necessarily contain one type of event. So one of the attributes in the core event is this event type. So you could have something like account created or... That's the most typical one, actually. Like, everyone uses this kind of thing, like account created, or you could have like transaction created, or you could have profile updated, or dishes washed, whatever event. And then, but you can have all these different types in a single stream, which I think actually leads on to one of the most powerful parts of it. And obviously we'll get there later, but yeah, that's quite interesting.
Cool. So you mentioned the term streaming then, and I keep on hearing the terms event sourcing and event streaming. Are they pretty much the same thing, or is there a difference there?
That's a very good question. Honestly, like I have a feeling that an event stream is just a part of one of the concepts of the event sourcing. It is more of just actually a pattern. It's not really like an architecture or like a big overall thing. It's it's like a very specific pattern. And I guess, part of one of that patterns is event streams. But this is where the interesting thing comes out of it, because actually, if you start talking about, and we should at some point start talking about the RX reactive extensions, because that's all about streaming stuff as well. And I think it's all around this concept of just like time moving forward. It is essentially, I think, around this concept. And we're definitely going to be getting into that in a bit for sure.
Nice. That could be a whole episode if we're talking about RX.
well, this is it. Like it's all part and parcel of this stuff. And once you go down this rabbit hole, it's a rabbit. It's literally like Alice in Wonderland rabbit hole. It's like you fall through the bottom of the tree, and then suddenly you're in this whole new world. And it's it's awesome.
It does sound like, from when I've done bits of event sourcing before, that it's kind of quite a paradigm shift as well, because I think a lot of developers are used to, you've got a database, you write some data, and the database is storing the current state of that database. And correct me if I'm wrong, where event sourcing, you're only storing the timestamped events as they happen. And to get the current state of the database, you've got to replay them. Have I understood that correctly?
Yeah, and I think that's a brilliant segue to where we should actually start this conversation, because I think if we bring people on this journey, I think you might actually starting to understand this, like where this all sort of comes from. And it's a great place to start, is this whole like idea of like, I don't know what caused it or what point. I know there's like several points throughout programming history where things just suddenly became entrenched in a certain way, like OOP. It was in like early 2000s where OOP suddenly became this animal gets inherited by dog or cat or chair, and you get different types. You get this like really weird sort of like idea of OOP, and I wasn't always that fond. I actually found it quite hard to understand programming through the lens of OOP and all this inheritance and stuff. I was really always put off by it. So when I first started my first job, and the principal engineer was like, "Oh yeah, composition over inheritance," I was like, "That makes so much sense." like composing stuff over inheritance just makes so much more sense, where you can join a few bits together and that creates a whole new thing, where rather than having these really vast object hierarchies that just like make no sense. Like I don't know if that's ever been a thing. Like I don't, to me it's just never really like helped me solve anything using these massive object hierarchies. Yeah, so like one of the big things that sort of came about, I remember the shift between web forms, ASPX, and MVC. And like for me, like I did a bit of PHP before, so I was quite used to this whole like push, pull, request, response paradigm of the web. And ASPX just never really made much sense to me. And then I saw this MVC and I was like, oh, damn, that looks exactly what I want to use. So I started using that. It makes way more sense. But then for me, that started to bring in, like, I don't know if you ever noticed, like the technical separation of concerns. Like I call it, the separation of concerns is like part of this whole solid thing, isn't it? But I see more as like there's this technical separation of concerns. And you get this like model view controller, and then everyone's got these models and they create these entities. And I heard someone coin this. I don't know if you ever heard this coin, like a UI to the database. Like you just end up creating a UI to the database where you've got all these CRUD things and you're literally mapping one-to-one of your entities into your database. I don't know if you've ever come across that.
And there's also the whole feature folders and vertical slices, which kind of like map onto that. But yeah, quite often, especially when doing APIs, I see code bases which the API response is returning the same DTOs as the database entities. And it's like, no, don't do this. Don't do that.
Right. And then someone thinks, I've seen it a few times where someone thinks, all right, because I've got my database entity and I'll just map it into what's called a DTO. And it's basically, they use AutoMapper to do like a one-to-one mapping of all the properties. And then that should be fine, right? I've now got a separation between, no, that's not right. It's not right. And that's where like this idea that databases end up just storing entity state. So they're just an entity state storage system mechanism. And I guess we all got to start somewhere. And that's where like a lot of us started. And I know like creating a lot of code first entity framework stuff and doing that. And then sort of like I started to come across these ideas of like, doing feature folders. And then principal engineer talking about Mediator and CQRS. That was very intriguing to me, using Mediator. And then I started to sort of like start thinking about these ideas of, rather than technical separation of concerns, going more towards this like behavioral separation of concerns. Because it never really made much sense to me. You get someone like on the UI, like a business analyst or something on the UI, and they're like, oh yeah, I press this button, it just doesn't do what it's supposed to do. Like, what button is that? When I was in the login screen, I clicked the login button. Like, how many people then go, oh yeah, you click the login button, right? So that then translates to the login controller. Oh wait, is the login controller or the authentication controller? Oh, well, hang on, where's this controller sit? Actually, what part of controller is that part of? Well, let me just scroll down all these like methods to try and find the part where that is. Like, it just, like, how is that's not useful? That's not useful to the developer or anyone, because it takes you ages to find out where things are. But if you, for instance, had a folder that said login, you'd be like, oh, that's where it is, in the login folder. Oh, look, it's got all the models to do with the login. It's got all the actions that the login can perform. So you can log in, you can log out, maybe sign up. It might be part of it. That might be in a different part. It all depends on what your domain is, I guess. But moving more towards that behavioral separation concerns is much better. But I knew there's that technical shift between MVC 3, 4 and the core, where I think the DI only worked with the controllers if they're in the same folder. They had to be in, like, wasn't it done by like convention or something, where all the controllers had to be in the same folder or something like that? But when it moved to like ASP.NET Core, you could literally put the controllers anywhere.
I'm not sure, to be honest. Before .NET Core, I tended to use AutoFac and just plug that in.
Yeah.
So it's only recently with like .NET Core and the later versions of .NET Core, then .NET 5, obviously can't say Core anymore. And actually, a couple of episodes ago, we had Steve Collins talking about dependency injection in .NET, and we both were saying the same thing, that actually everything we typically need is just in the built-in IOC container.
Yeah, 100%. And it's actually interesting. Like, I think like one of the biggest shifts that I've seen in the Microsoft code base going from the old style to the new style is the fact that moving away from all the plumbing static classes everywhere. It's like, like dependency injection was a nightmare because half the stuff was static, and like you had to like, they were done by like singleton objects and all this kind of stuff. And it's just like, there was no like interfaces, or like half the implementations were internal. So you couldn't really actually like use particular parts or break things down. It was very much like, here's your black box and that's it. Try and use that somehow.
Yeah, we're definitely in a better place. And I'm quite lucky that I know a lot of devs aren't fortunate enough to work on the latest and greatest, but I'm kind of quite fortunate that all my projects are like .NET 5, so I can use all the new stuff. I am looking forward to .NET 6 though, and all the stuff that comes with that, and Blazor and all. I'm quite interested in Blazor Desktop, but that again, this is going to be another tangent, which will be an entire episode. So we should pull back to event sourcing.
Yeah, although it does all tie in at some point, and I will get to that tie in later because that will tie in at some point. Yeah, so where does event sourcing come into all this? It's when you start thinking like in terms of how you obtain that data. When you start sending data to APIs in this user interface, when you start sending this data. So like if you imagine like if you're going to sign up to something, the really nice sign up screens aren't the ones which ask you for like every single bit of like information. Like there's like a ton, like a page as long as your arm, like give your first name, your last name, your date of birth, your mother's maiden name, your pet's favorite name, your address, your all these other details, all this stuff. Like no one wants to sign up to that. No one's going to sign up to your website if that's the first screen they hit with a sign up. So usually what you ask for is like, what username or email do you want to sign up with and what password do you want to use? And then throughout the process, you'll probably get things added with a bit more information. So that doesn't quite fit in with the traditional CRUD style that we've just been talking about. So it doesn't quite fit in if how you're going to design your database tables around that. You end up with all these like different relationships in your tables and like span across a load of stuff. And it just makes it a little bit harder to think about and sort of get all that together. And the other part of it as well, like if you imagine with these tables, I might actually change my email address at some point. I might change my address at some point, and someone might do that for me as well. So, for example, if you phone up a call center or whatever and you tell them, I want to change my address, that operator might be the person that actually ends up changing the address. And, if you've got a table which has like, I've seen this a lot, columns which say like modified by and last modified time. Like, how useless is that information? Because like, as soon as you get two modifications, you've lost the first modification, right? So that doesn't really quite work. And for me, like, I think a lot of this CRUD style just doesn't work with life, right? Life is about a series of events that happen, a series of moments that happen in a time linear format. Like, we're not going to get into quantum world, right? we'll leave the quantum. Go and look at number file if you want your quantum stuff.
That's another episode.
Yeah, that is. So how many episodes are we up to now? About 4?
I think it's a series. It's a whole new podcast, I think.
This is what happens when you get me on talking. Right, Callum's joined. Right, how many series are we going to create now? But yeah, so the idea is that like, it's movement through time. And one of the ways you can think about that is obviously that sign up thing. And then there's also this classic sort of like the event driven architecture, like the classic analogy for that. And it's like going to like Costa or Starbucks, where you go in, buy your drink, they take that, they palm it off to someone else. A ticket with some information on that person, then does something, adds to the ticket or whatever, says what drinks they've done. If there's something that needs to be cut, someone else will take the ticket and sign off that, especially like McDonald's as well. Like McDonald's is the same thing. You go up to the machine, you put your order in, someone might be on the burger duty, someone might be on the fries duty, someone might be on the shakes or the whatever, and it gets passed around, and this ticket gets passed around and things get checked off on it, like more information is added to it until it finally, someone checks and goes, oh, everything's there. So they go and collect it all up, put it on a tray and then give it out, and then ask for who is it, whose ticket is this, number 48, come up here now. And then they start yelling it out because the person who had number 48 forgot they had number 48 because they're blind drunk at 3 a.m. in the morning. That wasn't me, by the way. I was number 47. I was definitely number 47. I was very copious.
I was wondering whether to ask, but I didn't want to offend.
I don't think I've ever forgotten my ticket. I'm usually the person who's like, who forgets their ticket number? Like, so I'm always like on it. But I'm sure there'll be that day where I'll be like laying on the McDonald's sofas, being like 32. But yeah, so that's sort of like the event-driven way. And at the core of that, there's this event picking up more information as it goes around. And it's like those core concepts, which I think is what, I started to play around with, and I started to think about, like, actually, as I wanted to create my systems, I didn't want to try and get all this information right now, because you might not have all of it. And I sort of want to build up this information as you go forwards. And I started some work around councils and sort of lining up postcodes and people who lived at these addresses. And I hadn't heard of event sourcing at this point, right? And I think it was about 2015, maybe 2016. So event sourcing was a concept that started in about 2000. Well, from what I can understand, started in about 2006 with Greg Young and his papers. And at least there's definitely going to be in the show notes a video by Greg Young where he goes through this, so you'll be able to get all that information. But one of the interesting things is, like, because of the way that they stored the information about where these people live, like, they stored them like as that people and their addresses where they'd lived and all these people's addresses. And I was sort of linking everything up via these postcodes and the address lines. So actually I could see a timeline of all these things happening. And we also needed to search it. So I was really into Elasticsearch at the time. And I still am. Like, Elasticsearch for doing text-based searching is amazing. The DSL is a pain in the backside for trying to remember and get it to work. But it is quite cool for searching, right? And I think it was the time when ES6 started to gain some traction in the JavaScript world. And they were starting to, like, you started to get these things like JSPM and Webpack started to come about. And this is like the grunts and the gulp era as well, all these task-based builders and things like that. And that allowed you to use some of these newer features because they could obviously transpile the code back to ES5. Oh, I also wrote some ES3 at that point. I wrote ES3 in 2015. Isn't that crazy? ES3. Oh, it's grim. Don't use it. They don't have JSON serializing.
Are you still having nightmares from that then? Or?
I think I have. I've got PTSD on ES3. Like, my mate, actually, he used to, big shout out to Ben, but he used to work on JavaScript, on really old JavaScript as well. And we'd just be sat there, like, just cringing at all the really bad JavaScript we had to do. And it was still, like, in 2015, 2016. And it's like, what? This is crazy. But yeah, so one of the big things that was coming out as part of that is this, like, object.assign, where you could stack up all these objects into object.assign and it would then flatten it out into your final object, right? And I was thinking, that's quite cool. So in my UI view, what I could have is this timeline with all the data. And as I'm dragging the timeline over, I'm passing the array of objects into this object.assign, and it's flattening them down for me. And I'm basically just, it's really hard to explain, but I'm crunching it down at each different point. It's flattening these. So if I started on the left and I had 6 events and I had the slider at the first event, it just showed me that first object of that data. And then as I slide it across, it then flattened the first 2 objects together, and that would give me my final look at data. Then as I slide it across to the third one, that would give me the last 3, and that would squash it into that view. And then and as you can imagine, as it keeps going, it gets me to that. And I was thinking, that's pretty cool. So what I thought is, like, let's have this property in my Elasticsearch object, which basically had all the data, like all this stream of events, right? And this is where it started to click for me. I was like, oh, damn, that's really cool. And then I joined Just Eat, and the manager there was like, have you heard of event sourcing? And I was like, and then I didn't do anything about event sourcing for the next 3 years, I think. And then I picked it back up again. And yeah, so I think the core of what this revolves around is the idea that you get all these bits of information via these events. And you've got this, like, append-only log where it's an array. Think of it like an array-based log. And I think that's even the Kafka. We had a talk from Confluent while I was working at Nationwide, while I was consulting at Nationwide. And we had a Confluent talk. And they were like, they literally built Kafka around the idea of an array. That That was how they built the databases, around this idea of an array. And one thing that we all know, that the characteristics of array that make it really performant. I hope I get this right. Otherwise, I'm going to get like bombed by the Twitter community and everyone who listens to your podcast. But like the characteristics of the array is like moving from one element to the next, and the linear thing is really fast. Being able to go to the next element is really fast. And obviously, like implementation details matter. So depending on how you've implemented your array, but generally, incrementing your index is really, really fast. And so the idea is that you could start at the bottom of your set of events, and you could then increment, go to each event, and you could start crunching it all together. And that then gives you your entity state. So actually what we're doing is the core paradigm shift that we're looking at is changing our ideas from being entity state to like a time series of events. So what you're doing is you're storing the bits of the state, and then at any given time, you then serialize all that state. And actually, like in the real world, that makes sense, right? Like, you wait for all the bits of information before you do something, right? So one thing you could think about is when you start cooking food or something like that, you go and consult your recipe, and you be like, right, I need all these ingredients, and you go and chat, I've got the carrots, I've got the onions or whatever, I don't have any meat, so I'm going to have to go out and do a shop, go and get some meat. And then once you've got everything, you can combine all together and then start making your dinner. So the idea is that once you've got all of your state together, when you can start pinging at different points and be like, what's the state at this point? What's the state at this point? Because it's ever changing, right? And then you start to move into the realms of like this eventual consistency stuff. And it's quite interesting because I put this conversation point out into Clearbank about the eventual consistency stuff, because I think some people, especially if you're dealing with banks and money and liquidity and stuff, especially with liquidity, people want to know exactly how much money, because you want to know how liquid they are at that point, right? Especially when you've got millions of pounds moving through the payment system, tens of millions, hundreds of millions of pounds moving through the payment system. You need to be liquid for all that money that's moving through. So it's that's part of the regulations, I believe. So yeah, it's very important to be liquid. So they kind of say, we need to know the state at every single point. But I think, even with the eventual consistency, it's about, you pick a point and you say, what is it at this point, knowing full well that in 2 seconds time it could be different. But that's the point. Are you asking it, what is it at this point in time? So yeah.
Just thinking about different use cases for this, if we're storing events over time rather than just the current state, it feels like there's lots of different advantages. So I suppose another example might be a simple to-do list app. If you've got a to-do list app where you've got a desktop app, a web app, a mobile app, and you're creating to-dos, deleting them, changing them, and synchronizing all that together, if each device, when you're doing an action, is just storing a timestamp, and that timestamp is the source of truth, then you don't have to do any synchronization code, because you get it out of the box, because your list of events is timestamped. So you just sort those events by timestamp, replay them, and all your different devices are synced.
Yeah, this is the really interesting part around it as well. And I think one of the things you hint on is that in that UI, when you think about it, if you start with the UI, what causes things to happen? Events cause things to happen, right? You have a button, it's an event. Most of the stuff that happens in the browser is all done off event handlers, right? The eventing model in the browser and the JavaScript stuff is the core driving model of how we do things. It actually ends up making a lot of sense to build your architecture in an event-driven way, because you're driving, everything gets driven from events. I'm going to go and do something, that's an event. I'm going to go and click this button, that creates an event. Everything you do creates these events. And yeah, so like you say, you end up getting these events, these stream of events in, and at different points you're like, actually, I've got all the streams of events that I need to kick off a certain task or produce more events. You can actually have events kicking off other events as well, right? So like when you've got all the right events happen, that might kick off other events. So in payment terms, it could be like reconciliation events. So once you've got a certain set of transactions through at a certain period of time, maybe that might then end up kicking off another event. Especially like if you're like talking about Amazon and like ordering something, like you've got your shopping basket, you've paid for it and all. As soon as you paid for it, that's going to kick off a whole series of events. You can have events where that paid event might kick off events like checking the stock or getting the stock thing sorted or getting the delivery driver prepped, or all that other back office stuff that happens might be spawned from one event. So yeah, it's really good in that sense. And then also going back to this idea of, replaying the events and working out where you went wrong and where you got to. Because if you had it just as entity state, because you don't have all that information about what created that at what point and how that was created, you don't understand when your database is wrong. You're like, why is that wrong? What did that? How did it do that? But if you've got an event store, you can then replay all the events. You can actually, usually what happens is when you create a service that is reading off the event store, depending on what kind of service it is, you usually just keep a track of the last event that was being read, and you just keep reading. Or if it's like a push stream, you keep getting pushed these things, but you generally keep a track of where you've read from. But if the service goes down, you reboot the service and you say to the service, right, the first thing you're going to do is read from event 0 and rebuild all of your state from the first event. And you can then rebuild it. If you want to work out, where something's gone wrong, you can spin up a separate service, replay all the events into that service one by one to see where something's gone wrong. You go, oh, look, it was when the addition of this event, this then created this weird behavior, which is kind of cool.
If you've got to replay events to find out what the current state is, and your application's been going for 10 years and you've got millions of events,
yeah,
do you have to replay from the very start of time, or is there a way of I'm going to knowingly use the term snapshotting like different points in time? But
yeah. So you bang on there with this snapshotting idea. So Greg Young talks about the fact that the event sourcing and event store stuff sort of comes from the accounting world. And what they'll do is they'll have this, what they call, and I'm literally directly quoting out of his talk at this point, they have this like year end thing where they basically, once they go to a new year, they roll up everything into a brand new start point, and they start from that point onwards, and they start adding new events to the year start. So the idea of snapshotting is you want to hold all that event data for, like GDPR reasons, however long you're allowed to store the data for. But it doesn't necessarily mean you have to have that in your working set of data. And actually, you can pick the right sort of period that you want to roll up data. But whatever that period happens to be, what you can do is you can roll it all up. So say, for example, account balance. You don't keep track of the account balance in terms of like entity state, but you can keep track of it as part of all the transactions that have happened over a period of time. And then you might think, well, on a monthly basis, if it's like FPS, faster payment system, where, tons and tons of transactions are coming through all the time, then you're going to probably want to roll up every month and start midnight on the first day of the next month and say that's where I'm going to, the account balance is X, Y, Z. And then you're going to start stacking all the events on that. So if your service happens to go down the day before they do that, yes, you will have to replay all the events across the last 30 days. But if your service goes down 2 days after the roll-up or the snapshot, then you only have to grab the snapshot and roll up the next couple of events. So you can have that kind of performance optimization in there, which is kind of interesting.
So if your service doesn't go down though, and it's just running day to day, is the software like Event Store, is that actually keeping for you the current state? Can you access that without having to, every time you do a get or query, replay all those events?
So this is the interesting part, right? So this is where you get to start deciding how you want to do that, right? And this is something that I'm starting to explore as well, the different ways in which you can do that. Interestingly, one of these big enterprise patterns with event stores is like the CDC. And the CDC is this change data capture. And Kafka has these like CDC plugins that you can get, change data capture plugins. So one thing that you can do is get your database, use its logs, which is essentially an event store, use the logs and pump all of those logs out into your event store as all the events. And then all of your systems from that can drive off of the event store. So you can suddenly turn your database either into read-only, write-only, whatever you want, maybe write-only if you're reading the logs or whatever. So you can do that. And then obviously if you use a few different databases, you can stream them all into the same, event store. And then all of your microservices at the top, depending on how you've done your domains and stuff, you can then decide, what streams you want to read off of, how you want that data to look. The change data capture layer might have transformations in it to which creates new streams. So you can actually have streams that create other streams via Event Store has this idea of projections. So you might have these two streams, and then you might have a projection which which takes these streams right into a new stream. And then once you get up to the microservice level, you can then serialize that data into however which way you want it. It might not be totally in the right way. You might want to discard 3/4 of the data or a quarter of the data or whatever. And then what you can do is patterns where the data feeds into your service and then you pump that into Mongo or an entity state. You pump that into your entity state. So you pump that either into Mongo or SQL or Elasticsearch or whatever you want to do. So yeah, that's an interesting pattern. One I'm looking at the moment is actually keeping that in memory. So you might be quite familiar if you have like a users, right? You might have a user table which has 1 billion users in with all their user IDs, right? But when you come to sort of the event store world, what you might do is actually have a stream for each user, because that kind of makes sense, right? Because each user will have all of their streams of data attached to them.
I'm just wishing I had a product with 1 billion users, to be honest, after saying that.
Facebook? Yeah, I know. That would be amazing, wouldn't it? We wouldn't be having these discussions. We'd be having these discussions on a private jet, wouldn't we?
Or on a beach or something.
Dan Clark's private jet podcasts. Yeah, so you might actually want these in terms of like user streams, these individual user streams. So you might have a stream, each stream might be user dash their ID. And that's where it gets kind of interesting about where do you want to store it, whether you want to store it in memory. If it's a stream that is maybe, and this also comes into the like how much data do you get on a day-to-day basis for this particular stream as well. Like I can imagine if it's a transaction log, you probably don't want to have all that serialized into memory all the time because that's a lot of data, unless you had that 128 gig of RAM to put it into. But say for profiles, if you're storing a profile for someone, that might be like 3 or 4 events max. It might be the event of like adding the address, adding your personal details. That's like 2 events, and then you might have changed your email address. So like it's a really low volume of events. So that you could actually like genuinely just keep serializing that from the event 0 every single time, which is actually quite interesting because that also like crosses the concept of like Phoenix servers and Snowflake servers. So like, this whole idea of being able to use, what's the name of it? Like things like Pulumi and the other one that everyone knows, and it's the most popular one, but I just can't remember the name of.
Terraform?
That's the one. Terraform. Using all of this where you can like keep rebuilding your infrastructure over and over again. You can just destroy, being able to tear down your whole entire thing and rebuild it the exact same way every single time using Event Store. Like for me, that's a really interesting concept, because doesn't that really like increase your resilience and reliability when you've got full faith in your services just get destroyed? Like, because like Kubernetes, for example, you got pods running left, right, and center. You don't care about your pods. Like, if you want to spin up 5, 6 new pods, they should be able to do all that. And if suddenly some administrator comes along and goes, we need to just kill this node and boot up a new node, then Kubernetes is going to make sure it's going to bin pack the rest of your services onto different nodes and respin them up over there. So you want to be able to just destroy stuff gracefully and spin it up somewhere else without the worry that there's some kind of like Snowflake configuration that's just suddenly like now, like Snowflake, once they melt, they're gone, right? So that's the idea. Like once this pod's gone, like, oh no, I've lost all of that specific configuration that I decided to put onto this pod for no apparent reason, So that's another interesting concept.
Yeah, I'm definitely a big fan of configuration as code. So if it gets destroyed, you can just spin it back up again, and no one should be going into any portals like the Azure portal and changing settings. Yeah, that's another one of my pet hates.
It was like Kudu or whatever, going on Kudu and something, bringing up the PowerShell or something, yeah. FTPing all your files onto the server.
Those were the days.
Oh, they were. Oh, look, I've brought down the whole website. I wonder why this has happened. Oh, I put them in the wrong folder and I deleted all the originals. Damn it! Yeah, no, I know those ones. Yeah.
The whole, you're doing a deployment by opening up a Word document and manually following a whole bunch of steps from a Word document.
Yeah, which is not version controlled or anything like that. So, last modified by Jeff. Jeff, God damn it, Jeff. You gave me the wrong instructions. Now the whole thing has gone down.
Oh, you've worked with Jeff as well.
Oh, this Jeff, man. What a guy.
I probably shouldn't even go on this tangent, but anyway, many years ago, before I was a consultant, one of the companies I worked for was Rebellion in the games industry, and there was a cat that always just used to appear behind the offices every day, and someone nicknamed him Jeff. Then, after I left, many years later, I saw on Facebook that someone had put a picture of Jeff on Facebook saying, like, Jeff is like basically talking about him, and he was still like years later. I saw that. I was like, what?
Brilliant.
How is that still a thing?
Some of these things just will never die, will they? And
I know.
forever go on. Yeah. So one of the interesting things, like with this whole event store stuff as well, is going towards functional programming as well. I'm actually a massive functional programming advocate, and not just any functional programming. Obviously, F# all the way. And I like using F# because I like the idea of writing a lot less code than I do in C#. I do use F# and suddenly you're like, oh, I've written like 5 lines because I've missed out all the space, all the new lines and braces and all the other gaff that you don't need. But yeah, like this is something that really fits quite nicely into the functional programming paradigm. And Event Store has got .NET libraries, C# style. So you kind of have to do a little bit of a translation there for your F# stuff. But it just fits so nicely because with F# you've got these types, right? And types aren't classes. Yeah. So I don't think you can inherit from them and all that kind of stuff. They didn't act like that. Scott Vlashen talks about them as like, think of them like sets. So if you've got the type of int, that's a set of all the other possible values of an int. So that could be, if it's an unsigned int, 0 to whatever. If it's a signed int, it could be minus whatever to the other bounds. Then you get these 2 different types in F#. You get these AND types and these OR types. And so an AND type is like something and something and something and something else creates you your type. So that's more like a record. So you could think of it like profile data. So something that makes up a profile is the name and the last name and the email address and whatever, telephone number. That could be that. That's the sum type. Then you get this OR type. And the OR type is, as you can imagine, it's something that is either this or this. And that's where the combination of decisions is where like it makes event sourcing quite powerful in functional programming. It makes it quite easy to do because you end up with an OR type, which are all your different events that can happen. And then one nice thing you do in F# is when you do your discriminated union, which is what these OR types are, it's called a discriminated union. When you create your discriminated union, each case you can say event, and then you can use the keyword of, and then you can give it another type. So you can actually strongly type the different cases. So you could say you can have all the different events plus their, of the type of this event record. And so whenever you build up your system and you build up your domain model and you build up all your events that you're creating, you just end up having it part of this one big discriminated union. And then as soon as you feed these events in, you just have massive match expression over your main event discriminated union, and you just match all the different cases. And as soon as the business come along and say, we need this new feature where we need to create this new event and all this kind of stuff, and you go through all the ideation of that, and then you create that or whatever, and then you add that into your event, your discriminated union, suddenly all your F# code blows up because it's like you need to now manage that all the way through your process now. So it highlights, say it blows up, actually what it does is it highlights all the different areas in your F# code where you need to manage that new event. And then you work through that process and you attach all that data. So it's something that actually works. It goes hand in hand with functional programming and F# really, really nicely. And it works really, really well together. But that's not to say, obviously, you can't do that with C#. You just don't have the type system at your disposal or as your friend, because obviously when you create classes in C#, they can obviously be inherited. So when you do a switch case, you always, I don't know if you've noticed this when you do a switch expression, that you always end up having to put like a catch-all all the time because for some reason it can't determine all the different cases that you're going to happen.
I think with each version of C# it gets closer and closer to F#, doesn't it? So maybe one day we'll have something similar.
You know what? I was actually thinking about this, and I don't know. And obviously, like I'm who is it? Mads Torsten is the C# architect. Yeah. So like he can correct me if I'm wrong, but I don't know if C# could ever actually get there because it is like one of the fundamental differences between C# and F# is the type system, and the algebraic type system doesn't sit or play so nicely with this inheritance idea. So you should always be able to understand all the different cases in which something needs to be evaluated. Although there are still a few caveats with F#, obviously, because it's got to interrupt with C#. So there are still caveats in that. But I don't know if C# could actually do. But I could be wrong.
Yeah, I think because C# is trying to do both worlds, then there's always going to be limitations. and backwards compatibility. We know that Microsoft are quite big on backwards compatibility, which for
Yeah.
good reasons. There's lots of code bases on all the versions of .NET. So whilst they're doing lots of language improvements, it's kind of an incremental append kind of list of improvements rather than rewriting the language.
Yeah, I was always sitting there with my fingers crossed, hoping for the day they delete the 4i loop. The most basic and not needed looping thing, 4i, like.
I don't know when I last used that, to be honest.
No, exactly. I mean, I think the only other time I've ever used it when I was mapping 3D matrices onto 2D matrices to like get 3D images to display on the screen, and you end up doing like the double 4i 4y or the 4x 4y, the double iterations through the.
In fact, I'll tell a lie. I have got some code that does that because I've got some image manipulation code which does exactly that. So
yeah, yeah. Whenever you get to image manipulation, aren't you? You're always looking, going through the coordinate system of the image, just trying to like apply things.
Was it span times y plus x or whatever it is?
Yeah. I have no idea where we're going to with this.
Well, I think we should probably get back on track. So going back to what you mentioned, we did touch briefly, and you mentioned like things like CQRS and Mediator. And this kind of feels like where with CQRS, where you're separating out your reads and writes completely. It feels like this is perfect for that, where your writes are presumably just events being emitted, but then you need to handle reads in a different way.
Yeah, so this is another really interesting part about it, and which direction you go is again like completely up to you. But I did mention Mediator and that, and so CQRS is something that was it like the command query segregation principle, something I don't know, something like that. But Greg Young talks about it, touched on it. I think a lot of this comes from like domain driven design, and obviously comes from the it's all part of what makes up domain driven design, and from like from the account stuff and getting a lot of the ideas from the account stuff. And one of the like I'd say probably I don't know whether it comes on like the tactical patterns of DDD, but it's using CQRS. And to be honest with you, like I'm not overly bothered by that separation that they put there. But I like where Mediator went with it, where they were like, yeah, we don't have commands or queries. It's just a request. You send an I request to and a request handler picks that up and then it does something with it. And I kind of like that because, obviously they didn't have F# in the unit. So you have this like, I think Jimmy created this unit type. Jimmy, as if I know him by his first name. And like, Jimmy Bogart. Yeah, that guy. I've never met him, never talked to him. But yeah, Jimmy, Jimmy, Mr. Bogart, when he created that unit type. So you could do like I request of unit. And so like you could say, if it doesn't return anything, it just returns unit. But I think it's interesting because I can't remember, was it Scott Vlashen or was it Mark Seaman I was watching? And they probably talked about it, both of them probably talked about it. But when you look at a signature in .NET, when you look at a signature and it says like public void or public string, blah, 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 and it throws an exception inside of that, they talk about that signature lies to you because it doesn't actually tell you what it returns. And so it lies to you about what it can actually do. And I'm obviously paraphrasing massively. I don't want to get like Scott Vlashen getting on Twitter. Like, you're so wrong.
This is one that the F# episode you mentioned, that was a group episode and Scott Vlashen was on there. Yeah. And I think this was a point he actually raised on that episode.
Yeah, 100%. And it's about, this is what's nice about having an expression language because you have to return something and everything returns something. Even if like it, you don't want to throw exceptions all over the place, right? Because they do come at a cost, but they also don't mean anything and they can throw you out of the flow of a system, right? Because a lot of people, they throw exception and the unhandled exception handler comes out from nowhere and goes, I found an exception, let's do something with it. It's like, what? Okay, you just throw me out the fray.
I can't hear the phrase unhandled exception now without, because obviously that's the podcast.
Yeah.
It's like if I write some code that throws an unhandled exception and I see that, it just looks weird.
Yeah. Yeah. Oh, man, I get that. But yeah, so like, these exceptions they're not useful. Like they're good for the libraries and stuff because they can be like, look, this is not supposed to have happened, right? So use a JSON serializer and you sent it some JSON that just doesn't make any sense. And it goes, no, JSON format exception. Don't really know what I'm going on about here. And he's just like, okay, fine. But you want to catch that. But if someone sends you some data, that there's a possibility that the data they're going to send you is crap. It doesn't make any sense, right? So that's a normal thing. So that's a validation error, right? So it's a validation. So you send it back as your rest. It's like a 400 bad. Is it 400 bad request?
Yes.
So yeah. So you just send that back, right? So you always return something, right? And if you think about it as well, like if you think about command line applications, when you write those, you return back an integer. So everything has to return back an integer at some point. And that's what's really nice about the expression language. It forces you to return back that particular thing. Whereas with .NET, with all these exceptions and stuff, it can throw you out the flow.
I guess with your example with the 400, so the bad request is if there's something wrong with the request. But I guess an API can throw an exception for other reasons as well. And at that point, it's probably a 500 you want.
Yes,
and
exactly.
But then your API, I suppose that is a scenario where an exception might be useful because an unhandled exception, ASP.NET does then return 500. But you need to be careful with what's being exposed to the end user in that exception.
That as well, and what do you log as well? Where do you log it, and what do you log, and what's the stat trace that you got back, and is it useful and all that kind of stuff. So you kind of want to catch that at the point where you can sort of handle it, even if handling it is just sending it off to the logger and then sort of returning that 500. It then leaves gaps in your application, but like the unhandled section is that it is good that it does return that 500 and that, but you shouldn't just let everything fall up there, right, and catch all exceptions and then rethrow and all that kind of weirdness. But going back to the mediator, right? So everything can return something or other. So I'm kind of happy with just doing with this request response sort of model with it. The handler, especially if you go into feature folders with the BDD, you get these handlers which end up, handling very specific tasks. Like I need to get this thing, or I need to do this thing, I need to push this thing, or I need to, and I just think it just allows you to do this level of separation, which I don't think you really get with controllers. Although they're starting to, and have you seen the thing where they're starting to, I don't know if it's ASP.NET 6, where you can sort of like have a method anywhere now. You can just annotate it with like HTTP get or whatever. And you don't need it to be in a controller.
I've not seen that actually, no.
No, we might have to look that one up.
Is that part of the minimum API thing?
No idea, but I saw
good
it,
answer.
And it's stuck in my memory. So
nice and honest.
Yeah, it's something like you don't need controllers anymore or something like that. But you have to look it up. But I leave that to listeners. Go homework. Go and look it up. See if it's a thing. and then send all of your responses back into Dan's Twitter.
Answers on a postcard.
Yeah, that's it. Yeah.
With the mediator thing, it's kind of, I just find it has lots of different advantages because, like you mentioned about one responsibility.
Yes.
At the moment, I don't know what the .NET 6 changes are, but at the moment, if you've got an API endpoint which has get, put, post, whatever, they're all in the same class. Well, normally they're all in the same class, so it's good. But that they might be having completely different responsibilities. Where having a handler, one thing I quite like about mediator as well with these handlers is, quite often you've got application logic in the handler. But actually, that shouldn't care whether that's been executed by an API request or a message on a queue. Yeah, it's just business logic. So by separating it out into the handler means your business logic doesn't care what's executing it.
Yeah, exactly. And what's really nice is the mediator library is a really small library. And what it actually does is it creates a barrier between you and any other framework. So I actually built a media player. And that's this one thing I've been using to learn everything I've learned about programming. I've got like 40 versions of this one media player. And I've got it in WPF using Mediator. I've got it in MVC using Mediator. And I can put any different UI I want to put on it. And I don't really care what the UI is, whether it's WPF or whether it's web or whatever.
This needs open sourcing.
Which version? There's one in Node as well somewhere around the place. But yeah, so that's what's really nice about Mediator. It creates a separation, and then, like you say, it's sort of this barrier to against getting tightly integrated. And one thing I did with Mediator was I created a ASP.NET Core Mediator glue library called Liaison, which the idea is that you can do sort of like, if you ever done like Node and you've used any of the web frameworks, you can usually do something like a root, give it the root, .get, .post, and then you can put the handlers in there.
Like Express.
Yeah, that's it, using Express, Koa, all that kind of stuff. So what I've actually done is you can do root, pass your root in, .get, and then put a generic constraint on of the request. And then my library will handle fully deserializing from the request into a mediator request and then pushing that off into the mediator, mediator.send async or send now that they've removed the async stuff. And it just goes and fires that off.
How does that handle things? So one thing I not struggle with Mediator, but it's more like the whole avoiding taking shortcuts and making sure I'm doing it right. But obviously, a controller or an endpoint in ASP.NET has to return a status code, so okay,
Yes.
not
Yeah.
found, or whatever it is.
Yeah.
But you don't want the mediator handler to even have a
No.
concept of those status codes. So there's this mapping layer between there, which I always it's extra work, and it's one of those ones where you kind of want to take a shortcut, but then you've got to stop yourself and not do that.
Yeah, so I generally just have I have like an application response, and I just send it out through there. And again, it doesn't, C# makes it a little bit harder, but F# does it really nicely. And one of my F# APIs, I've literally just got this really fat discriminated union with all the different responses that you can possibly give, from anything from transient database errors to successful. I've got your data. And really, when you think about it, when you return data, you're boiling down to two status codes, 200 or 204. So you're either sending something with content or you're sending something without content. So I end up just having this general thing which just wraps that up automatically for you.
That's a very happy path.
Yeah, very happy path. Yeah. Because we're developers, we don't really care about the unhappy path, to be fair. Who cares about the unhappy path? If it doesn't work, it doesn't work. Don't look at me. It was the other guy.
Ship it.
It was Jeff. God damn it, Jeff. Always causing bugs. But yeah, so what's interesting actually as well is like this concept and stuff, like this event sourcing concept and all this kind of stuff it has actually protruded into other things. Like, so one of the things I want to, finally to wrap all this sort of up is Redux. I think has everyone here heard of React and all of that and Redux? I know Angular. I'm not endorsing Angular, and I have my own opinions about Angular, not favourable ones, but so the people got to use it and they make a livelihood out of it, which is amazing. And Angular's got this RxJS built in, which is really cool. That RxJS stuff is really cool because that's reactivity and streams of data and working on streams of data. I just don't like Angular's style of views and that. But when it comes to React, I like the way that React does it. Its view is driven off of the JavaScript all in one place. You're not sort of got these two, those weird declarative if statements and stuff like that. You've got real if statements pumping out different sorts of stuff. So I like that. And then you got like this Redux, and everyone uses Redux or goes to it, or they might not anymore. Who knows? It all moves on. But I love using Redux, and Redux has got this idea of streaming events around the system, right? And then Redux has this store where all of these events goes through a reducer, and the reducer essentially takes any event in and then gives you a way or an opportunity to then push that into the store in some kind of format. So make changes or whatever. And one thing that I've been moving towards, because obviously event driven is kind of the way I want to go. I want to be doing everything in event driven, even my smaller stuff, even stuff like which is one system sized. I will do event driven. I'll get people who be like, "Whoa, it's too small. You can't be using event driven for that, or you can't be using event store for this." Oh, I will.
Oh, I will. You can.
Yeah, if you try hard enough.
There was a point when my blog was running on Kubernetes. So I've seen that comic where there's like a big massive truck with nothing on it and a little box in the middle of the truck, and it says that's someone's blog running on Kubernetes.
Yeah, no, that's it. Yeah, if you try hard enough, you can make anything do anything you want. So
it's all about learning, isn't it?
Well, this is it. And to be honest with you, I want to make it my the only way to get really stuck into anything is to live in it 24/7, right? All jokes aside. So what I've started to do is, this is why I made that comment right at the beginning about this WebSocket stuff, right? So now with everything, I have one WebSocket handler. And I'm not saying this is the best way to go. It's just what I've done. But I have this one WebSocket handler straight into a Redux store. And, with UI does whatever, pumps the events down into the WebSocket, pumps into my F# service. That then discriminates against all the events or whatever, pushes it into the event store. And then the event store comes back up, then I've got another background service running, the hosted services. I've got that running, which then reads the events, creates the entity state at that particular point, and then I can push that back up via the WebSocket if I want to, which is just it's just doing that loop in this one process, and in this real-time stuff. It changes the way that you program this stuff, right? So I was sitting there thinking, I'm building my own piece of software and I want to send notifications when something happens, right? And I was doing it with Mongo, and I'm just like, yeah, but when do I send this notification? How do I get this notification back? And it's like, oh yeah, I'll just stick in WebSockets. And then okay, so I've saved it to the store. It comes back, and then I'm pushing out. I'm just like, that feels really weird and really I feel like I'm doing it a bit cack-handedly. So I was like, well, I don't like that. But now I've got this full, like, it goes in, and when it's written to the database, it then fires off these notifications or whatever, and it feels like there's a proper loop, and it's going around in a proper loop. Data comes in, gets stored into the event store, comes out the other side of the stream, and then goes straight back up the other way, and it feels like so much nicer to deal with. And I think that's one of the power of using event stores as well, is that it comes with this real-time aspect. As soon as you've added some more data, it's firing off streams and projections and creating new streams or adding data to other streams, and you can then listen to that inside your services. Where this is where we can be talking about RX, the reactive extensions and the whole new thing that I think it was it .NET Oxford? You had those guys in talking about their RX stuff.
Yeah, so we've had a couple of talks. So quite a few years ago, we had James World doing a talk on RX specifically. But then earlier this year, we had the Engine team.
Yes.
We had Carmel Eve and Ian Griffiths. And they were talking about the Reactor platform, which is basically RX at scale for, funnily enough, high-performance event processing.
Right. Am I right? So this stuff all links back in, and it's pretty cool. And this is that whole loop, which I think just makes it pretty cool. And then what the bits I've started playing with, and this is where I'll leave people at, and where we can sort of start to wind this stuff down, and I'll leave people with this, is that in Nationwide, I was creating this GraphQL service. So this GraphQL service, all nice, shiny, new, sitting in Kubernetes, handling their main website stuff calls. And that was then palming me off calls left, right, and center to all over the place, whether it be to like some of their, whatever their content management systems were, and then to whatever back office systems were. Like if it did that, I don't even know what it connects to these days. But, I created that. And GraphQL is really awesome in the sense that, like, you give them this schema, and then you get to specify the bits of data that you get back. Right. So you can be like, I want this bit, I want that bit. So I want the person's name. I want all the books that they read. Off the books, I want the author. This is the classic GraphQL sort of thing. Off the books, I want the author and the author's name. I want this person, this profile, his address, that address, the location for that postcode. You can bring back all these different bits of data. So you just chuck it, all the data in it, and then you can form these schemas. And then if you do it via the federated services as well, it means you can start giving the domain teams the domain ownership. You can start separating these GraphQL services out into their domain teams, and they can look after their schemas. So as a consumer of these schemas, you can go and have a look at what that team is outputting all the data, and you can be like, well, I want those bits, I want that bit. And it's no good just doing it over HTTP REST, right? You want to be able to sometimes stream this information, right? How many people sit there and go, well, if I could just stream this information, right? Why can't I just pull this information rather than having to poll it all the time, right? So yeah, and you can use this GraphQL stuff. And what that made me start thinking about is pushing this partial bits of data, is actually thinking about, rather than thinking about things in entire entities, think of them in partial bits of data, and then pushing that into your system, coming around, and then having GraphQL sat on a bunch of different services, all pulling all these different bits of information, and you can just pull that through. How that actually all works is a very good question. I've got a simplistic view of it working, but the partial bits of data and just dealing with all the little bits of data is definitely something I've not had a lot of play around at the moment. But when you do all this kind of stuff, you get to start using all these other technologies like gRPC for the real-time streaming, this HTTP2. I mean, even HTTP3 is coming out, right? So you could even be using HTTP3 and that kind of stuff, and sort of trying to move away from this like really old REST HTTP 1.1 entity state request response model. Like, that's not how the world works. The world works in this event-driven way. Things are firing off these events left, right, and center, and you want to then at some point in the future, you want to serialize that into some kind of view at that given point and do something with it. And I think that's what the core of Event Store is.
Yeah, it's very, very cool. And it just feels like such a big mind shift for a lot of developers. But you're right, events is how the world works. But I'm very mindful of the time, because this is probably going on to one of our longest episodes. So is there anything else you want to cover before we jump on to dev tips?
I would just finish off with definitely go and look at things like DDD, primitive type obsession, creating actual domain objects, but also understanding the importance of DTOs, because serializing into a domain object might actually be quite difficult, but serializing into a DTO and then moving that into a domain object, suddenly makes your life a lot easier. And then then you work towards your event store that way. To definitely look at a lot of the domain-driven design concepts. I've got a big book on my table, Implementing Domain-Driven Design by Vaughan Vernon, which is a very, very good book.
I've actually just started reading, funnily enough, Designing Event-Driven Systems by Ben Stopford, I think it is.
Oh, link it.
We'll include all of these in the show notes.
Link it.
Knowing this podcast was coming up, I thought, actually, I really do like event kind of architecture. So I just searched on O'Reilly. And so I've started reading this. I'm on like the second chapter in, but yeah, it's all really interesting stuff. And this covers a lot about Kafka and all that kind of stuff.
Yeah. Also, for the people like with Event Store, go and look at stuff like tombstoning for like GDPR and stuff like that. That's quite interesting. But there's a talk by David Schmitz called Event Source, You're Doing It Wrong, which is a really good talk. But basically, really, implementation matters. And go and start implementing this stuff to really find out what you need to do for it, really. That's the final closing notes, I guess.
This is going to be a long list of show notes.
Link the entire web. Just give them Google.
Cool. Shall we do dev tips?
Yes. You first. I'm still trying to think of my dev tip.
Oh, no.
I give out so many. But yeah, go on. You go first. What's your dev tip?
Does that mean I've got to think of one as well? Because I'm in every episode. It's getting quite difficult to like think of them.
That's why I'm making you go first, because I'm like, what's this, episode 342? You're going to have to...
I think I've got a long way to go for that. This is 26.
I hope you've got enough dev tips for that.
I might change it to just tips, maybe.
Tips and
stuff. So my one is it's basically just saying don't hesitate to ask for help if you're stuck.
Oh, God, yeah.
Well, I'm guilty of this as well, but quite often, if you hit a problem or you're just trying to do it, you end up sometimes go down the rabbit hole, and then you're just in this silo trying to work it out, and the next thing you know, like a few days have gone. And actually, just before that happened, just have a discussion, even if it's just using someone else as a rubber duck, so like rubber duck debugging, where you're articulating the problem to someone else, and quite often that helps you solve the problem yourself.
100%.
There's nothing wrong with asking for help. I think that's my tip, because it's such an important one, and I think a lot of people are scared to admit that they don't know something.
Yeah, I think the key strategy for that is time boxing what you're doing. If you're thinking, God, I just have no idea how I'm going to do this, that's fine. You know, everyone goes into work doing that. They have no idea what they're doing. And but if you time box it and say to yourself, like, I'm going to give myself 20 minutes, see where I get in 20 minutes. You know, you can take stock checks of these different parts. And really, if you're getting really stuck, time box yourself to like half an hour, because so many times, and being a principal, I know this. So many times you get people come to you like the next day and be like, "What? How do you do this?" And you're like, "Oh, that's simple. You just make that change there and you're done." And like, I've been Googling this for like 2 days, but like, no, just time box it, because someone's going to have the answer. Someone's going to know that. And now that we're using Teams and IM as like one of the biggest communication things, like you're not really going to disturb someone if you just push them a message and be like, I just can't figure this out. And even I do that, still. It's
not just what you mentioned about you being a principal. It's about everyone's got different experiences. And sometimes it might be someone that's less experienced than you that has just got a slightly different experience, or in the past has had to Google a particular problem that you've not had to Google. It's kind of...
Oh, yeah. Yeah, 100%. Principal doesn't mean much; it just means I've been around for a long time. But really, like, I love talking to every kind of engineer, inexperienced one to experienced one, because you get to listen to all the different things that all their experiences and all of these combined experiences are just so interesting. And they come up with, a lot of the way that I think and the stuff I think about has come from, all sorts of different people, even people outside of engineering. So, yeah, absolutely. Yeah. Cool. That's a good tip. I like that tip. What's my tip? I think my tip is try and be really accepting of everything. I know like there's always been this like contention between like C# and Java and all that kind of stuff. And I've done quite a bit of Java, and from my own experience, I hate it. but Java does some stuff that's really quite nice. Does some stuff that is better than C#. And when I started learning F# and I took a few people on the journey of learning F# and myself, just opening my mind to all these different things that F# does, and looking at Haskell, even though there's some things about Haskell I really don't like, some things I really do like. And when you start to open your mind to all these different things, learning things that are changing the way you think, when you're learning these new things which are changing the way you think, you can bring that back into your own programming language like C#, if that's what your language is, or JavaScript, if that's what your language is. Like for JavaScript, you want to do functional programming, go and do Ramda.js. Bring Ramda.js, and it does all the partial application and the currying for you. And once you bring that into your language, you then start to look at things in a completely different way. And this is something I'm doing at Clearbank at the moment. I'm taking people on this F# series, this 10-part series of learning F#. And, it's basically just me getting stuff wrong and on a camera for half an hour every week. But, it's about getting people engaged, but on something completely different they've not experienced before, and get them to think in different ways. And if you're really open to that, then you start to really gain a lot more experience, and you'll start walking up that experience ladder a lot quicker, I reckon, if you start trying to open your mind up. So I say, yeah, be very accepting and open-minded. Don't just sit there and be like, Go is something across the fence. I don't want to ever, touch that. I don't really care about it. No, go and look at Go. How does it do threading differently to C#? That's really interesting stuff. And by learning that, might gain some new pans that you could actually bring to C# to make it more efficient. Who knows?
Absolutely. I think also it's important to have the right mindset. It's quite easy to think, I've got to learn this other technology that I need to learn for work. It's what a pain. I don't want to learn another thing. Or you can think, yes, I've got another thing I can learn, and this is really cool. I'm getting to play around with different paradigms or try different things. It makes my job less boring because I've got much more variation. I'm not doing the same thing every day.
Yeah, and the strategy for that is like I said before, I've got 40 versions of a media player. I love music. I love creating this media player, and I learned everything I've done. And for programming, I learned everything through the media player. Like I learned how to do recursion because I was looking at folders and file structures and trying to search and scan, and I had to do recursion for that. I learned that through making this media player. So find something you really love to do, like something that you find really interesting. I know one of my mates, he's using guitar. So he's using guitar as his thing. So he's been making all different apps around his guitar stuff. And that's how he's learning all of his programming stuff with, some coaching and mentoring here and there. But that's what you got to, what you got to do is you got to find something you find passionate about and then start trying to translate and transpose that into these different things and make it much more fun for yourself. 100%.
Definitely. So before we wrap up, where's the best place for our listeners to reach out to you if they've got any questions? Or obviously we'll include links in the show notes too.
Yeah, I'm all over the place. I'm all over Reddit. I'm all over Stack Overflow. I'm all over Twitter. I'm all over LinkedIn. But yeah, Twitter and LinkedIn is probably like the best place. Go and hit me up on Twitter and LinkedIn. I'll probably just let you, like, my handle's a bit weird, so I'll probably just let you let you link me in Twitter when you put out the shout out for the podcast. But LinkedIn, just hit me up at Callum Linington LinkedIn and look for the guy. I'm pretty sure there's not many Callum Liningtons in the world. got a pretty unique name. Pretty happy about that. There's no other Callums in the world, that's for sure.
You're talking to someone whose name is Daniel Clark, which is like the most common name on the planet, I think. I can't believe I actually got the domain name danclark.com.
You're lucky.
I don't know how I got that. There is a racing car driver called Dan Clark, and he did actually reach out to me years ago saying, can I have your domain name?
Oh, really? You're like, no.
Well, I said, you can for a lot of money. And
that's it. £10,000.
Well, I think I said more than that, to be honest, and he went quiet. So I was kind of...
Yeah, that's how you get rid of people, isn't it? It's be £2 million.
I think I said 15,000 because I thought, well, if he gives me that, I'll accept it. But it's a domain I want to use for years, so it's kind of, I'm not going to give it away for nothing. So
you should just be really spiteful and come back and just create danclark2.com. Cool. Awesome.
Cool. So yeah, a massive thank you for joining us on the show. It's kind of, I think we've got the record today for the most number of technologies we've mentioned in an episode.
That's me all over. Yeah, amazing. Thank you so much for having me on. This has been awesome, and it's been so great to have a chat about this. And yeah, I hope I wasn't too just reeling off all the words in the universe.
No, that's fine. I can just edit them all out. It's all good.
Just edit it all out. It comes out in like 5 minutes. Amazing.
Brilliant.
Awesome.
Cool.
Excellent. Thank you.
Cool, no worries. And thank you everyone for listening. And a quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. And if you're enjoying the podcast, please do help me spread the word on social media. I normally use the hashtag unhandledexception, and I can be found on Twitter at Dracan, DRACAN. And and my DMs are open. And my blog, danclark.com, has links to all my social stuff too. We will include links to all the lots and lots of things we've mentioned today in the show notes, which can be found on unhandledexceptionpodcast.com.